good to have you guys here, and I hope we get more people here. Yeah, and I hope we move on. We can start doing this regularly. So if you don't know me, I am Murray. I am new to integrated projects. I say that, but I've been here about 2 months now, so I feel like I'm part of the furniture. Um, yeah, which is great. It's such an amazing team to be part of. And part of that is to research and learn about the process that we're in. The scans bin process that we market and we offer to our clients is can be fraught with complications. And so I want to have these chats to figure out the details on the various parts of that. So, today to kind of kick that off, I've got Mark Carroll, who's just finished a pretty illustrious stint, 5 years or 4 years at Matterport as senior sales engineer, I think, Mark. And from what I read, you have been part of Matterport's great rise over the last few years, which is really
Yeah.
interesting. Yeah, yeah, and so it's
Hey,
great to have you on board, Mark. Yeah, hello.
how you doing? Thanks for talking to me today. Yeah, I was at Matterport for about 4 years, just under 4 years. I did have a lot of experience using different tools, but included various tools that were supported, like the Leica BLK 360 laser, and seeing other devices in the field and hearing feedback from people about the use of different devices. So I'm happy to talk to you about it because um, it's an interesting area of discussion because it's so important, but it's also growing very quickly, and it's new to a lot of people, in my experience.
Yeah, well, that's very much it, isn't it? So you and me have both been part of this process for quite a while, and so we get the details, or we've heard all the details growing as they're coming along. But if you're new to reality capture and you're coming in from the outside, there are very high level scanners, there are very entry level scanners, and there's all sorts between, and there's a lot of noise from everybody. Everybody either thinks theirs is the best or everybody else's is terrible. It's a hard thing to navigate if you're not in the industry, is it not?
and and I feel that sometimes it is, there are a lot of promised results. Like, if you get this, then you will get this. But the caveat is there's a lot to learn, and you may have to hire a new person or train someone that you have, train them up in new skills, or think about changing what you do entirely. Maybe that old paper that you're peeling off into the construction site, and you're getting 15 copies and handing them away. That is going to change possibly in your comfort level, but there's that person as well as very experienced people who may have to come back from high level detail to say you don't need to have that small detail. Maybe you can bring it down a little bit and expand the way you capture and consider different inputs.
Yeah, very much so. And there's very much a wide kind of scale of required outputs that people on the one hand, a lot of people just need to know the square meterage of their space, which you can do quite roughly. And on the other hand, I've worked on projects where you're trying to model some intricate heritage kind of molding. Those are the times when you do need as high a detail as you can, but you've got to be careful. That detail costs money, so you've got to choose. Do you want to spend
Yeah,
huge amounts on scanners and etc. etc.
yeah, exactly, exactly. It's a fascinating area, and it's always growing too. So
Yeah, absolutely. Um, so So how do you choose? How do you, if you're either an architect or you're not necessarily an architect, how do you choose what level of scanner you're aiming for?
I usually I'd start at the reverse, kind of like, I guess, another problem solving type techniques is you have the result that you want, and I would go in this area. The result or the answer you need is what kind of resolution do you need? Is the information you're going to capture help you to go all the way to plans that you may submit to your city, to your municipality through different regulations? And are there regulations about this, or is it different type of detail you need for, like you said, older structures that have historic surfaces or different materials that you want to be able to capture, and just because. So I think that really guides what tool you're going to use. But of course, the other input is cost, but also time too. So it's kind of like any type of project. But I think that the first guiding principle would be, what's the type of resolution that you need? And I always think of the person at their workstation, and will they be frustrated with the results that you're giving them, or will they be overwhelmed with maybe the size or the detail, like, oh, this is too much kind of thing. Getting that readout of what do you need kind of stuff, that drives the laser, or purposes, or different types of technology that are out there to grab 3D data.
Yeah. Yeah, I absolutely agree. And looking at that person, that guy at the workstation, that might be critical because yeah, the guy, especially if you're scanning and it's becoming scan to BIM, so you're scanning and it's going to be outputted to BIM. Um, there's only so much detail that either you want to or you can add into a model. Uh, and the guy at the workstation, often when you have the very high quality scans, they're huge in terms of file size and RAM usage and all sorts of things like that. So there are disadvantages to the high level ones, very much.
Yeah, and that was one of the things that I would do. So in my previous work at Metacore as a sales engineer, with different conversations with customers, I would talk about some of the things that they may not consider at first. And um, what fascinated me was the idea of decimation, or decimation process at the end of the line. And so for those who aren't as familiar, but you have a tool that captures a very large point cloud, let's say, and it's so darn accurate that you have to tell a program that you pay for as well with a large license fee to literally cut out sections, to just remove it. But you were in the field capturing that data. So you're sitting out there with the laser, gathering stuff, watching that laser spin, and then you have to go home and delete stuff.
Yeah.
What's the deal? And so for the salesperson, it's one of those things where it just makes sense, and you can talk about it. You can rationalize it. It makes sense. So that's where it gets into other areas of, if the building is leaning a few centimeters, and we need to know if it's sinking in the mud, or it's just some XYZ spot that needs to get a quick rundown for putting a new conduit pipe to see what kind of conflicts you have in an existing model that you've already created. So it's like a tool belt kind of thing. What you need from your tool chest. But that's how I would talk about it with that previous work. Was just what you're saying is the results will guide what tool you use and what type of detail you need, and also helps plan out in the future so you can repeat it, and it's not just this one fabulous masterpiece that was so hard to do, and you're so exhausted that you couldn't imagine doing it again. And that's not scalable either. So it's that kind of healthy honesty, I guess, to your workflow that I would suggest.
Healthy honesty is nice because I imagine because what you're saying, I've just lost my train of thought, but that you're creating something that's repeatable. That So I mean, since I left architecture a few years ago, and I've been doing scan to BIM only for the last 4 or 5 years, and
Yeah.
it's almost it's incredibly hard to estimate how long something's going to take and to repeat it, to have this system where I know what scan I'm getting in, and so I can repeat that and get the right output. There's a whole lot of kind of learning to model, which is super specialized. And so on the one hand, you've got scanning, which I guess is your side of things, and on the other hand, then that scan comes to the modelers, and we've got to decide again how much information do you want in the model, and ideally you relate that to the scan, but really you relate that to the requirements, and often the scan doesn't match the requirements, or actually the model we're producing doesn't match the requirements because we've gone over the top of what people actually need. Yeah.
Yeah. Indeed.
Yeah. So
Yeah.
I wanted to ask you, how did you get into scanning? If you've been at Matterport for a long time, I was looking through
Yes.
your career experience, and there is boating at the racing team, and which became CNC automation. That
Yep.
sounds
Yep.
like
That's
how you
right. It
got in,
was
and that sounds amazing.
mostly it was networking. So I guess this could be a rundown about just keeping your options open to different possibilities. So I worked before in rowing, and like the long skinny rowing boats to see in the Olympics and things like that. And it was coaching and things like that and rowing myself. And as time went on, I got into sales. I was a history student, and they say in history you can do two things: you can go teach history or go and be a lawyer. Well, I didn't do either. The third thing was do sales. And so that's what I did. So in sales, I luckily was able to incorporate my sport of rowing into sales, where I was a salesperson for Wintech Racing and had different roles. And there was a phrase that I would actually say, and my coworker Brendan, I would laugh at this. I had a coworker Brendan from Wintech, but the idea of we're here now. We're here at this race course. We're here now. Let's get to work on the boat. Like, what the heck? Why put it off? Let's get to it. Or you're here now. Let's do the work that we need to do right away. And so I think about that going back to my work experience at Matterport. The idea that if a person gets into a workspace and they're scanning, whether they're snapping pictures with a cell phone camera or doing a video camera on top of their hard hat kind of thing, and buzzing around doing videos for different capture, the idea that your time in the field is being used at that time. You use it how you want to. And maybe it goes back to my sport of rowing, the idea of you're on the water a certain amount of time, you use it. What you can't row on the water when you're in bed or when you're driving to work and that kind of stuff. So my background came from that kind of working and rowing, and I networked with a fellow who was property in Chicagoland, and we got property management and then property development and different construction project management. And then they incorporated Matterport. They just, my coworker Demetha saw the value of three-dimensional data and things like that years ago, and invested in Matterport, buying a camera, the original Pro 1 model years ago. And that was the start. I was just given the camera, say, take care of this thing. It's expensive, but it's valuable to use for the property management of their newly acquired property. And it was different types of property. Sometimes it was distressed financially. Sometimes it was physically distressed, where it was a broken down building, or sometimes it was a beautiful new building that was also financially distressed. So it was that Matterport usage that was the guide that connected me to Matterport.
And talking about Matterport usage, so there are all sorts of different scanning devices on the market, and Matterport, one of the huge ones. What's the spread? So there's Matterport. I would put Matterport and the BLK kind of in the middle, but and those are both terrestrial scanners. But
Right.
what's outside of that, and why are those the most dominant devices?
Yeah. I think Matterport fits the gap between, let's say, hand measurements and then laser devices, with the BLK 360 being like, let's say, an entry level laser within the professional construction zone. So if you have the BLK on a scale and different devices that are comparable to it, that same company, Leica, makes a tool called the RTC 360. I can tell you that I've heard that device mentioned very often on sales calls, because teams already own it and they use it already in the field. I was able to get my hands on one years ago when I was in London at a trade show, and I went to the Leica booth and was talking to a person there. And it's a great tool. It's fantastic if you haven't seen the way it works, and you move it around, and it has these different cameras that you see as you move, and it has different tools on the board. Real slick stuff. So things like that, or different devices from company like Carroll or Trumbull, like different devices in the field that have different levels of fidelity, let's say. But I would also guide it with to say, is your building leaning? There's a story that one can research in New York City. I'm sure different cities have the same thing, where a
Mm.
building is leaning. And how is the building determined to be leaning? Well, somebody noticed it at one point, but someone gets a laser up there to figure out if the building is leaning. And so that technology is employed to define, for very, very large cityscapes and things like that. But also, I think that the use case goes into it again to say, for example, if you have a building where you're going to get cladding on the side of the building, that's, of course, fireproof and things like that. But does it fit? Maybe there's custom bespoke corners of an older building and you're replacing the cladding. Can you get a laser to shoot the building and determine the real measurements and then send them off to manufacturer to make sure that that information is usable for the end user? Now, it's definitely possible, but the idea of the type of laser and then the integration with the manufacturing, and I have a background in machining, so I got a little bit of experience, not as much detail as this, but suffice to say, if someone was going to do that kind of a thing, you'd have to have the right tool. Otherwise, let's say a tool like the BLK 360 wouldn't be sufficient for that kind of let's say. So I would say that within the industry, but it can also go back into lower scale. I think about a camera or like a telescope, kind of like a microscope. So you can look very closely. And again, to the manufacturing, if I was going to use a laser to determine quality control down to a very small scale at a fast rate, can I do that? Or if I'm going to laser scan a countertop in a home to a scale that I know is suitable for my CNC machine to mill out a marble countertop of a custom nature in my large CNC machine in my plant. So I think that it's again guiding the end use case, but when it gets into larger manufacturing and design of property and like you were talking about, older buildings. What if a relief on the edge of an old building gets crushed during I don't know, something hits a tree falls, and you say, I want to mill out that entire older relief. Yeah, it's not going to be the original craft people who did it, but yeah, we'll do it. Can you do it? And is the laser sufficient to do it? And I think that that's exciting. And just to close up, my point of what I'm saying is, and what I said before about you're here now, you're capturing now, the idea that your presence in that space and the capture, the imaging, whatever you call it, the lasering you do of the interior of a building, it's everything that you would need in the future. There's no detail more you would need. You just pluck out the data you need because the scan was sufficient for everything. And I think that it's a middle ground between maybe that really expensive laser of a higher scale, and then some other kind of combination of different qualities. I think that would result in the most efficient. It's like a changing of the idea of how you're capturing is. You capture everything, but you have to make sure to pluck out the right information that's not going to overwhelm you.
Yeah, that's right. And so, like, so far, sorry, I wanted to say, I was supposed to say at the beginning, if anybody's listening to us and would like to ask a question, firstly, please, I'd absolutely love you to. But there's two options. One is you can raise your hand in here, and then we'll let you speak. Or I believe in the events channel on Discord, if you want to type a message into the events channel, we'll have a look there, and we'll get Mark to get his comments. Yeah. So that's admin. On the scanner. So, is quality of scanner? What are we talking about when we talk about scan quality? Are we talking about how accurate that laser is? Well, I assume we are. How accurate that laser is to the actual point. Is there more to it than that? is there things like noise or things like
I would start with light first. And so I'm not an expert where I have like a degree in this. I was actually a history student, which I think I alluded to earlier. But
yeah,
the idea that there isn't a that when a laser is utilized in the field, and you can actually get this off the Leica BLK360 spec sheet. It talks about the albedo or the albedo, the light level of a space, and is that light level sufficient enough, or is the surface material possibly sufficient enough to be able to bounce that light off and back in some types of environments? I think it said something like 6 millimeters at a 10-meter distance. You have to have an environment that is very optimal for it. And I was doing like research about different spaces on in the solar system that are bright enough for such things. It's a very, very bright, where every day is that bright of a level of brightness. So essentially, the information that you're being presented now, it's a beautiful tool. It's a great tool. Don't get me wrong. If anybody
yeah,
from Leica is listening, it's a great tool. It is. But the idea of saying I'm going to get 6 millimeters off of every single rotation of the device I'm using, and in its native format, I'm not talking about stuff like Matterport, just using Leica by itself, a
yeah,
person would obtain the information, getting 6 millimeter accuracy at 10 meters throughout the entire space depends on other factors included in there. So I'd say light for sure, environment, if you live in an area or it's the type of season where it's more humid, a humid environment with more water moisture in the air, that would for sure affect different types of range. But each manufacturer, I think, would have its own benefits or drawbacks. But I think that going back to the one that I know the most, the BLK360, it could take several minutes for one capture, and if you do one of a more detailed nature, and this probably goes for other devices as well, objects in the space can move. And so if you're taking imaging that's going to be the color overlaying the laser, and
mm,
later on you're going to take the information out, the texture may not match the points that you get, the coloration, because stuff moved, because it'll rotate once for imaging and rotate once. It's first once rotate for laser, but either way around. It captures at different rotations. So over 4 minutes, things can change. It's going to be important for your use case. Maybe person's use case may not be. It might corrupt or make it more time consuming. Things like that. You said noise. Workers going through a space. I know different laser capture technicians who will not go into a space if there are people working, because the detail level is high enough where if there isn't enough overlap or they're too far away from each position that they capture, there's no way to verify. No
mm,
way. There are certain programs that will allow you to say if there's overlap, but for the most part, if you go out there and later on, going back to your workstation, going back to the earlier example about different workers not getting an idea of how long things will take, the idea of taking those scans and you have 25 positions and there wasn't enough to unify them all, so you have to return to the space. So that's one of the drawbacks too of I think very high resolution laser systems
mm.
bring a lot of detail, but it also brings large laser file size and time consuming processes that have to be satisfied every single time, no matter what, like I talked about earlier.
Yeah, yeah. And so I guess there's two streams of people. On the one hand, there's those who are reality capture service providers, and on that hand, kind of the operations of actually capturing that space, like you say, light levels, surface materials. We've all worried about mirrors and windows in the past,
Sure.
and people moving through your space or trees. Foliage is impossible as far as I'm
Right.
concerned because there's no way to keep it still. And so there are those people, but there's also the people who are actually only, they don't need to buy a scanner of any sort because there are a lot of people with scanners out there, but they do need to hire somebody with a scanner. And so they've got to be asking the right questions. And while they're not necessarily in the space doing the scanning, if it's too dark or too shiny, that's still going to affect the output. And I suppose so there's two sets of considerations. One is, are you the reality capture service provider? In which case, there's a whole lot of things. I think humidity, I've never thought of, to get the right scan. On the other hand, if you were a client, how do you ensure you've got to think through a lot of those things to ensure that you get the right scan as well? Else you're going to hire somebody and they're going to come back to you and go, it was too dark, so we got a bad product, and that's what we're into.
Right. I think from
Yeah.
the start, people, the person who's going to capture, yes, they do not have to own the device. I think that's probably the best bet to get somebody else to help you with one as like a test run. But I'll say this, that of course you can purchase a device, anybody can buy a device, but knowing how to use it is the most important. I think that you have a device and you go into a space, and if your business is the HVAC system, the heating ducts, or your the MEP for the electrical person you're working on, if you don't move the device into the area to gather, then it's not going to be useful for the end user. So, one small caveat to put in there too is the distance away from the scanner itself to the surface being examined is important. So if you're going to go into a room, pipes in a basement or a cellar, and different kinds of boilers and all kinds of fittings, if you're too close to an object, certain devices won't give you a result at all. And sometimes it might completely waste your time because it won't, the distance away isn't sufficient for it to work. So considerations like that are important because that should drive the use case. Yes, it can determine if my building is leaning a few centimeters off of center, sinking into the mud, like I told you so.
Yeah.
But it doesn't help you to go through every level to determine the state of the installation of the building when you hit pause because the building was shifting, to be able to determine next steps. So it'd be a mixture of things. I think that would be there to say, if you send out a surveyor to have a laser to do a plot of survey of the property line, and then all four corners of that building, and then the roof and the basement has been determined, then what? It's not, is it usable information? Even if you have an architecture firm give you a great model of an as-built or something like this, a very detailed Revit model, and they drop it off for you, then what are you to do with it? What's the point of it for you? So I think that really does guide the guidance of, it's useful because we can pull out 2D plans and utilize them to help the architect submit these to the city. Yes. And then we can use this kind of information, the scans in a third party, and have a partner overlay information for presentation. Yes, it all makes sense, and it starts with that first scan trip, I think.
Yeah. There's a question from Francois. He says, when we talk about accuracy, what is the relation of scan device accuracy and software processing the data to the point where scan to BIM can be started? So what is the relation
Yeah,
of scan device accuracy and the software processing the data?
absolutely. It changes. So I'm less familiar with the ins and outs of other companies. So I can give you a quick rundown of somebody like this, like a Matterport, but there probably is someone else who can fill in more detail elsewhere. The idea of the BLK 360 being supported by Matterport in its native format, the BLK 360 stores the 3D information on board. And you can obtain that through a laptop or different types of means. And that's its highest setting, its highest fidelity level. Now, with Matterport, years ago, when it was first supported for the BLK 360, you would have only a finite level of that clarity being transferred over, and that was because of certain limitations that were in place. This is years ago when it was first supported. These are not there in place anymore. So now,
Hmm.
because of that, Matterport can offer a richer file from that BLK360 in the format of what they offer is the E57 file variant. But separate from Matterport, let's just say there's a company that sells this scanner, and it's being put on the device, the BLK360. And you can utilize the information in different ways that you want. You can capture it with the Matterport app, and you can get a lower size. But also, there is a real value to that. It's not just because of a function of how it was first developed with the BLK360. The idea that if you in fact do not need to have the higher resolution file that does take multi-gigabytes, that does take time to process in a traditional format, I'm able to get what's called the Matter Pack from Matterport, or just kind of a 3D format pretty much. And it's sufficient enough to answer questions that the group would have, to model the installation of I don't know, new furniture, or some kind of flooring or new pipes. You can imagine the different things that go in there.
Yeah.
If the requirement does not need such high level of detail, then the platform is taking the 3D information from the original size, instead of ever having to worry about the original size from that original device. It's automatically being reduced into a smaller format that can be obtained and then utilized in industry programs, CAD programs. But instead of using the original format of the device, it's modifying it to a more optimal size. But this happens also not just with forget Matterport and forget the idea of using the Leica BLK360. Let's just say you're using a recap and recap from Autodesk or similar steps like that. You take a point cloud and you have to change it to an RCP or an RCS file if you prefer. The idea that you have to take the point cloud, you're changing it in some ways to translate it to make it in a more usable format by the end user. So regardless of the brand you're using, you're still converting it to be able to be understood in a more appropriate way by the Autodesk program that you're choosing. So it's the same kind of a thing where you always are going to have to modify the 3D data in some way.
Mm.
But there are other steps. There are companies out there, I'm sure, that are working to reduce that. But real quick, I'd say that not just lasers, other things like this platforms, things like photogrammetry. I hear great stories about cell phone towers and large scale farm spaces that are being plotted with drone, and that's all photogrammetry. There's no laser being used out there, but it's sufficient enough resolution and detail to answer questions about the terrain at that right scale, or that cell phone tower with the hanging parts off of the side of that tower. The resolution in just imaging data only from the video technology, that is satisfactory for those type of details as well. So the combination of tools in the field are, I think, very impressive for those kind of use cases.
Absolutely, and we haven't even spoken about drones at all. And I
Yeah,
believe there's LiDAR drones are available, although for prices that are prohibitive to everybody. But photogrammetry
sure,
drones have been doing fantastically, and we talk about detail that especially a kind of a mapping drone, that kind of resolution is horrid if you're trying to draw a building. But if you're trying to draw acres of farmland, then those resolutions are perfectly acceptable, and you can cover a lot
sure.
more space with the drone than you can with a terrestrial scanner. So yeah, it's all about choosing the right tool, I guess.
Yeah,
Yeah.
absolutely.
Mark, this was fantastic. I really enjoyed having a chat with you. We told everybody we would be here for half an hour, and I'm already 5 minutes over, so I'd love to talk all afternoon. But yeah, if there's anybody else who's got any questions they'd like to ask, I will be hanging around here for a little bit. And yeah, feel free to raise your hand and chat now. Or yeah, otherwise, Mark, thanks so much for joining me. It's been fantastic to chat. I have no doubt we're going to carry on chatting offline. Yeah, and lots of things to think about. Anybody else in the room want to add anything? Jose jumps on. That's a great way to do it.
Thanks, Mark. Thanks for jumping in, and Murray, thanks for hosting. Incredible job. I think, Mark, I'm curious. What's next for you in terms of your venture? I have to imagine it's some intersection between reality capture and business, but just curious to hear, yeah, what's next for you? How we can follow you?
Nope, nothing planned right now in stone. I'm still looking at different things. So if people have different ideas or projects they'd like to discuss, they can contact me. A little website portfolio called Edgebrook 3D. I'm a little in the neighborhood of Chicago called Edgebrook. So edgebrook3d.com is just a small portfolio of stuff and contact information. But I love the idea of job creation using technology. So what I'm really interested in is things like the different scanning technology that's out there. How do we utilize it to dispatch it to use just across every environment, across every part of the areas that are in cities and neighborhoods around. So that idea of just training people, that's the idea of using technology in the field. That's interests me the most. But this was fun, and thank you, Jose, for inviting me, and Murray for the discussion. It was great.
Absolutely, yeah. And I thought this was so helpful. I'm pretty sure our team's going to want to sit down and re-listen to this because there was just so many great sound bites here, just across the board. But yeah, thanks for jumping on, Mark, and definitely we got to get you back.
Right. Thanks a lot, everybody. It was fun talking.
Yeah, thanks, Mark, and thanks everybody. Yeah, that was fantastic. Let's close it there.